Hmm. Yeah, I'm working on some stuff.
Talking today about a really exciting development, what we've made with hemp grown by the Anishinaabe up in Minnesota on White Earth, and our vision for how we can be a part of this transition, the just transition, and how we plan to tether the materials, regenerative materials economy to the growing green energy renewables economy. Um, we'll talk about some of the issues that are kind of hidden in the renewables and the battery sphere, and some of the ways that we plan to address that. So thank you again, Lucille, for the warm introduction. Please put all of your questions and comments in the chat, and we'll make sure to cycle back to that as we close out on the presentation. I'll begin by sharing my screen. Please give me some thumbs up out there if you can see what I'm working with. Got some thumbs, nice. Then we can continue on. All right, well, again, my name is Jose LaSalle. I'm the founder and CEO of Hemp, and I can see more people are trickling in. Again, putting your ideas and your questions in the chat, and can't wait to talk with you all and engage further after this. So welcome to week 8 of Tribal Hemp 101. I hope you learned something here today, and let's dive right in. So I want to begin with issues that some of us might be closely intimate with, and many of us know about, and that is that we have this transition to the green economy, the green energy economy, and batteries are a big part of this. When you look at it from an engineering perspective, which is my background in electrical engineering and material science, they're phenomenal technology just for what they're able to do. But there are serious issues in the material reality of this technology and the way that we use it. 3 big things: safety, conflict mineral mining, and recycling. There are likely others, but these are the 3 that I'll focus on quickly here today. For example, safety. So this is an example of a fire that occurred. Batteries are often put at substations, and the Tesla's Megapack battery in Nevada, I believe it was, burned for days because this is not just a standard fire, this is a chemical fire. The electrolyte, meaning the charge carrying solution that's used in these batteries, is what's called an organic or carbon-based material, and this burns at its own rate. It's not something you can extinguish, at least not easily, and it's a serious problem that this solution is hindering. And so safety is a huge issue with chemical fires. Probably one of the larger aspects of this is the conflict mineral mining. And so we've heard of blood diamonds. Batteries are indeed blood batteries in many ways. The Nevada lithium mine proposed, for example, this will consume 3,200 gallons of water per minute. And that could cause the water table to drop in this area by an estimated 12 feet. And that's according to the Lithium Americas consultant. This is a huge problem for agriculturalists and ranchers in the area, and anyone who likes to drink water. So everyone. This is not a recognition. This is a distraction. This is a suppression of the value of water as life. Water as a life-bringing relative. And so this is the new green economy has these underpinnings that are very, very problematic. On top of this, it produces an incredible amount of groundwater contamination with metals such as antimony, arsenic, and so forth. And let's see what else here. Sulfuric acid is another issue and pollutant. There's an incredible amounts of millions of cubic yards of waste that's produced in this process, including radioactive material. So conflict mineral mining. Nickel, for example, is another huge issue in this supply chain. Nickel actually makes up the majority of a lithium-ion battery. And nickel is the #1 contributor to coral reef destruction off of Indonesia. And it is in the processing that creates sulfur dioxide plumes, choking the skies, as well as that end up into the rivers and turn the rivers red. On top of this, cobalt is a good portion of the supply chain from cobalt comes from child labor exploitation in the Democratic Republic of the Congo. This is, again, these are supply chain issues that all feed into this so-called green solution. Recycling is the other major issue. So currently, globally, recycling for lithium-ion batteries is around 5%, which is incredibly bad. There is actually a good story here that there is a significant amount of investment into creating highly recyclable batteries. And that has to reach a value, a cost value that will make it worthwhile. But 5% is very, very bad. And so with all of this, looking at grid battery storage, looking at electric vehicle storage, there is still, with all of this considered, there is the belief that this supply chain still is better than internal combustion engines. And there's an argument for that, without a doubt. And we want to move towards electrification and electric vehicles, but we need to find new solutions here. So we have some that are currently being developed. I like to talk about 3 that are outside of the scope of what I'm developing with my company, but I'll get to that after this slide. One, for example, is sodium-ion battery. This is, sodium is the 6th most abundant element on Earth, and it is incredibly energy dense. And new developments in sodium-ion batteries are getting closer and closer to lithium. In fact, the inventor of lithium-ion batteries, John Goodenough, is now focused on sodium-ion batteries and has confidence in their ability to meet and surpass lithium, especially as the cost is going to be a concern in the future for supply, for a dwindling supply. There are zinc batteries. Zinc batteries are decades old, but they're getting closer and closer to commercialization at this stage because they're going to be incredibly cheaper, as well as have a really high lifespan, so they'll last longer, and have a higher safety as well. The chemical fire concern goes down. And finally, we have potassium batteries, which are also potassium batteries have the capability to potentially be better than sodium and lithium-ion batteries as well. So 3 exciting technologies that remove the need for lithium, remove the need for cobalt, nickel, manganese in different forms, and can potentially be a part of this truly just transition. Other people are doing this work. It's amazing work. I want to talk to you all now about the work that we are doing here at Hempax. And I'll start with the broad story that we tell, which is that the trend we see in the grid is decarbonization and electrification. Decarbonization means we're bringing on renewables. Electrification means we're turning our transportation into all electric, and we're moving from gas-powered buildings to all electric buildings. The issue here is that as we go all electric, the power demands are going to create high surges in the grid. And batteries plus renewables don't stack up to that need, meaning renewables are a variable source of power generation. The sun's not always shining, the wind's not always blowing. And so you need to pair it with battery systems to store the energy when the sun's not shining and deploy that when you need to. However, this doesn't stack up to electrification because if you can imagine everyone getting home from work at the same time in an area and they have to plug their car into charge, or say there's a cold front coming into an all electric building space and the power demand goes up because the heating and cooling system requires a huge electric draw from the grid. And so what happens here is that the battery tries to maintain this power, but it doesn't. A battery in the chemical and power world is like a marathon runner. It can output a moderate amount of power over many hours, but don't ask it to sprint or else it'll struggle to do so and will have a hard time providing a lot of power. It also decreases the safety. What causes fires is when you try and pull too much power from a battery. And so a solution is a device, a technology called an ultracapacitor, which is also decades old, has been deployed on the grid. However, we're just doing it with a new spin, making it from hemp. When you pair ultracapacitors with batteries, you get the marathon runner and the sprinter. So the ultracapacitor is the sprinter. And when you have these high power surges on the grid, the battery hands the baton off to the ultracapacitor to manage those fast spikes in power demand. And this allows us to round out the full solution for our energy transition to an electric and decarbonized world. Specifically, what are we doing? When you pair ultracapacitors with batteries, we allow you to reduce the actual amount of batteries that you deploy, so minimizing your footprint, reducing the overall battery requirements on the grid, as well as extending battery lifespan. Early testing with our partners at the University of Washington, Seattle's clean energy test beds demonstrate a 2x multiplier on the lifespan of the battery, meaning that instead of lasting 10 years, it's going to last 20 years. Therefore, again, reducing the need for the amount of batteries that we put on the grid. And also reducing the cost to the utilities, grid asset developers, or communities that want to put up a microgrid system in their community. So taking a look at what's inside here, some of you, I'm not sure what you learned in the previous 7 weeks about hemp, but hemp is a phenomenal material. Hemp has characteristics at the fiber level, at the microscopic level, that lend itself to an incredibly good electrode material. Give me 1 second here. My dog is actually trying to step out. I'll be right back.
Pretty amazing, huh? It's crazy.
I hope you're liking this so far. So why do we, thank you for those thumbs. Why do we use hemp? Other people use coconut. Other people use silicon carbide and highly processed, highly energy intensive process. We use hemp because if any of you have ever held a hemp fiber in your hand and tried to pull it apart, or a hemp cloth, you'll realize that it's incredibly difficult. Hemp fiber was used for our Navy's rope exclusively back in the day. So what the word canvas comes from, the word cannabis. It was used as our sails. Manila paper was paper made from hemp in Manila in the Philippines. Our Constitution in the US is written on hemp. Hemp used to be a big part of our economy, and it was that way for a reason, because it has these incredible mechanical properties and it grows so well in many environments. It can be hard to process, but it's worth it when you get your final product. And the material properties that I was mentioning about the high strength when you pull on it, when you double click into that and look at the microscopic scale, the fibers are highly ordered and repeated. In other words, crystalline, meaning that the carbon chains in the fibers are densely packed together because the plant has an incredible capability of sequestering carbon from the air and turning it into plant biomass, plant material. So all of the carbon that it pulls from the air actually goes into the material of the plant itself and into growing. And it is phenomenal in the plant world at achieving this. And that same ability leads to a highly densely packed material in the fiber. That's why it's great for clothing, textiles, and many other things, building material. And so what makes it strong as a fiber makes it good as an energy material, because that same crystalline structure is what gives it a good surface area and conductivity when we make a biochar out of it. So a biochar is basically making a charcoal from the hemp stalk material, low oxygen environment, high heat. This converts it to incredibly carbonized and what's called a graphitic structure, so highly ordered structure of carbon. And once we create that char, we powderize it, we make a slurry of it with a solution, and then we coat it onto these sheets like you can see here. We coat it onto the sheets, you dry it, you hot press it, you slit it to size, and then you make what's called a jelly roll. I'm not making that up. That's actually an industry term called a jelly roll. And that's what you can see rolled out here. You create the jelly roll, and then you roll it up, and then you put it into the can. It looks like this. I don't know if you can see my screen. Put it into this can, and then you groove it, weld it, close it shut, and that's your cell. And so that is what we are doing here at HempX, is we are creating these cells from this hemp material, and I just walked you through the process. I hope that was fairly clear. But that is what we are doing. We take these, and then just in the same way that your electric vehicle is made up of thousands of cells, all of the devices that we would put onto the grid or microgrids will be made up of these basic building blocks. So what you see here is the basic building block of every product that we'll sell. So for example, we create a shoebox size module with 36 of these cells, and then 6 of those stack into a refrigerator size rack, and up to 25 of those racks go into a shipping container bank. And these allow flexibility for whatever storage deployment you want. So do you want it in your community, local community or neighborhood? Do you want it at the large town or city scale? Or do you want it on the distribution scale for a subset of cities and towns? It has extensibility in where it gets deployed, but it serves the same basic grid functions, which are handling the power and the peaks and the frequency response in the grid. Here's a picture Winona sent me of some young kids harvesting the actual hemp that we used and turned into our material. And these are some metrics that we are building out for the impact that we intend to have by building this business. And that is, with every megawatt that we produce, it represents 1.5 acres of hemp, 1.5 acres of grown hemp. For every megawatt, it also represents 9 metric tons of carbon that's been sequestered from the air. So like I mentioned before, we want to tether a regenerative, indigenized materials economy from growing regenerative hemp into the growing energy economy, so that both are tied together in a flourishing way. And when I say the energy economy, I mean the deployment of renewables and batteries and electrified systems. And so we want to create this tether to add success and build economic vitality back into the farming communities. This is a quick, low resolution view of what an example microgrid might look like. Having energy storage paired with solar panels, industrial processing, if you want to take what's left over from the hemp and turn that into, for example, hempcrete, or create seeds from that for food, or create textiles. All that ties in as well, health, homes, wind and solar, and electric vehicles, and building spaces. And this is just a quick view into our manufacturing line that we have at the University of Massachusetts Amherst, which is our base. This is our headquarters. And this is, yeah, this is one that will be getting up and running by this summer to be producing this at scale, at least for beginning prototyping. To give you a sense of timeline here, we are intending to run pilot tests with the refrigerator sized in 2024, and then to commercialize and actually sell commercial products in years after that. And so this is a long-term vision. We're on a good path, and we're not there yet, though. I don't want to give you the idea that you can, place an order today and take one home with you. But just wanted to give you a view of what we're working on and some of the opportunities that hemp affords us as people and as inventors and as agents of this change. And really most of the thanks goes to the plant, and the people who are growing. And so with that, I just want to say thank you all for taking the time to listen. And with the remainder of this time, I think we can spend some time answering some questions.
Yeah, that was amazing. I'm just floored at the like it never ceases to amaze me, the power of the brain and the ability to accomplish dreams in our wildest imagination and bring them into reality. So congratulations on that. I mean, that's really I'm so hopeful. It gives me hope. Grandmother Kim says she wanted to say mind-blowing possibility of this incredible plant potential. And thanks so much, Jose, for speaking at a level that we could travel with you. And Kelly also says, so amazing. Thank you, Jose. Paul says, thank you. A lot of thanks. Carlos Richard Sanko says, awesome presentation related to hemp products to electricity. And Richard is connecting with us from West Africa, and he's a representative of iSeed, and he's got his information in the chat also if anybody wants to connect.
Wonderful.
So this is so amazing that we can have an international group here.
Yeah, I see a couple questions here I can just start addressing. Can we use any hemp product in the manufacturing of solar power? This is a phenomenal question. I think any plastics that are used can be made from hemp. There are quite a number of groups who are making hemp plastics. When it comes to the actual material in a solar panel, it's mostly silicon and some other metals. And I'm not sure about hemp products, because what you can really get from hemp is carbon. There's a highly called a nanoporous carbon. Sometimes even you can create graphene from it. Potentially that could be used as a conductor instead of some of the other conductors used in solar panels, but I do not know. That's a great question I hope to be able to answer in the future. So I'll just go down the list here. Can you use solar panels to store electricity in the hemp cell? Yes. Actually, it's more efficient that way because solar panels are direct current, meaning it's not a wave for the way the energy is carried. And so that's the way that our ultracapacitor cell powers best. And yes, any electricity can power our cells, especially from solar. That'd be the goal. That'd be the goal, to have sunlight create the actual cell, create the biomass in the hemp that goes into the cell, and then sunlight being used to actually be stored as electricity. There's a beautiful story to be told there. Can you give us links to people doing hemp plastics? LaSalle, I believe, has some people who she could point you to. Additionally, there is Oregon State University. I know some folks there. I think even the Sisseton tribe. might also be doing work.
Jose, could we see your face as you answer the question? Sorry.
I should be pinned.
I'm still seeing your PowerPoint up.
Does no one else see me? Okay, Paul sees me.
We
Karen
can
sees
see
me.
you, but we can also see the PowerPoint. So in some people's screens, the PowerPoint will be very large and your face will be very small or somewhat
Oh,
hidden.
all right.
I
Let
don't
me
know.
just,
There you go.
I'll make that easier.
There you go, guys. Sorry about that.
Thank you for that request.
I just like to see the person I'm speaking with. Thank you so much for an amazing
Yeah,
presentation.
apologies. I was assuming that you were able to, but this makes it easier. I can take the screen down. Thank you. So links to hemp plastics, LaSalle, I'm not sure if that's something you could follow up with in the Moodle space. Perhaps it will be. But I'll send what I know to Lucille so that others can get connected. Question, would you most like us to retain other than an awareness that this technology is being assembled? What would you most like us to retain? I'd like you to retain that it isn't just us, by the way. We have a research partnership with Oregon State University, and this isn't a small, isolated thought. This is getting truly significant academic focus and investment, and that there is a true reality that I wish I had it with me right now, but we've made these cells and it works, and it's made from the hemp that's grown, that was grown by Winona. And I'd really want you to take away that, let that diffuse into our frame of mind and open up the thinking for ways that not only hemp, but regenerative biomaterials economy can be the cornerstone of our new economies, which is truly what we have, where we have to get to. I'm sure everyone here agrees, have a need, an increased urgency to move from an extractive economy to one that is regenerating. And so if there's another thing you can take away or retain, it's that is possible. And everyone's an inventor at some level. And if you have an idea, please pursue. Will the average consumer be able to access this development for personal home use? That is the goal. That is the goal. Like that microgrid diagram showed, we want this to be at the utility grid scale, down to the municipal city scale, local neighborhood community, and even behind the meter, it's called. Behind the meter means within an actual home or within an actual building. And our goal is to have the extensibility to be deployed along this entire range within the entire scope of the energy story. And where we're really headed for that is true energy sovereignty, right? Where we like to say it's a model after the way tree ecosystems, where there's a constellation of mother trees and hub trees, and an intelligence in where nutrients and energy is distributed and passed, that there's storage locally, and there are highways and channels through mycorrhizal networks for nutrients and information to pass. And the masting of pecan trees, for example, happens only when there's enough sugar collectively in the grove. And then they all mast at the same time because the collective is benefiting from the higher chance of all seeds being produced at the same time when everyone's able to collectively provide. And that same story, I think, is relevant for energy, where neighbors can have local production and storage of energy, production through panels or wind, storage through batteries and ultracapacitors, and to be able to shift around energy usefully and intelligently and collectively. for the communal good. And that is true resiliency, is when we're able to interconnect and share resources intelligently. So yes, intending for home use. Have you heard of the new release of the lower cost electric car by Tesla? Are you planning to try to partner with them or any other car manufacturer in the future? Yeah, Tesla's outlook is on just using batteries. They are getting lower and lower in their cost. I will say, it's a mixed bag with Elon and Tesla for perspective on them. One good thing that they've done is really revolutionize electric vehicles, so that is a good thing. However, there are valid criticisms. In terms of who we partner with, car manufacturers certainly are an open avenue for that. We're really focused on grid storage, so stationary storage for buildings and for the grid. But for electric vehicles, the main benefit there is really having our products deployed at charging stations so that we can be a local buffer and reservoir to handle high power charging that doesn't pull from the grid at large. Basically, it's a local reservoir to handle that charging. However, the new Lamborghini, for example, uses ultracapacitors in the vehicle because it's great at capturing energy very fast when you're braking, better than batteries, and at delivering power for fast acceleration, which Lamborghini purchasers really want. Formula E, for example, uses ultracapacitors. And so, yes, car manufacturers potentially. One that we're especially interested in are electric buses, and these have already been deployed in Shanghai and Paris, where the buses are outfitted with ultracapacitors so that they can charge up at each station within seconds. When they're dropping off the next cohort of people exiting, they will land at the station and they have a charging port on the top or bottom that flash charges the supercapacitor, ultracapacitor bank in the bus, and it's enough energy to get to the next stop to flash charge again. Very interesting concept, and that's already been deployed, as I mentioned, in those major cities with a lot of success. There are a lot of applications to get into heavy transport. One, for example, in shipping ports in the Baltic, when you imagine a cargo, so you have a crane that lifts up a shipping container, puts it on a cargo ship. When you're taking it off, you can capture all the energy of lowering it off the ship and put that in energy storage and use that to lift another one. So they've saved 30% of their energy use and cost by using ultracapacitors at the shipping dock. So a lot of applications here. Have you tried using a different plant other than hemp? And hemp did hemp give you the idea? I will say hemp did give me the idea. I wasn't the first to use hemp, by the way. There are some predecessors who did some great foundational work. We found our own innovation that brought it to the next level. We've used wood, we've used biochar wood, and it didn't work as well. We've yet to use coconut or kanaf or bamboo, but we'll try others. LaSalle, thank you for sharing Lone Star IM. This is a company that produces hemp plastics. Yes to rebuilding our soil. What is the difference in energy products between hemp plants and other hemp plants biochar products? Again, hemp's crystallinity of the fiber is the differentiator. It is the amount of densely packed carbons into the fiber itself and the fibrils in hemp that makes it different than other plants. So that is what makes hemp different and better in this application. Let me check on timing really quick. These are great questions, by the way. I hope I'm answering them well, but thank you all. How much time do we have to keep going?
We have plenty of time. The class ends at 6 p.m. and it's 4:40 p.m. right now.
Oh, 6 p.m. Okay, great.
And this
All
is
right.
awesome. Thank you.
Yeah, I'm loving this. What is the difference? The many ways the hemp land provides, innovates, and develops. Okay, well, thank you, Karen. That's really nice. Heather L says, does climate or temperature impact the energy systems you've presented? Great question. Climate and temperature have an effect on everything, especially batteries. And batteries do not like to be too hot or too cold. The beauty of this technology called ultracapacitors is that the temperature range is incredibly wide. So you can go from standard ultracapacitor, we actually haven't tested this yet for ours, but I will make a claim on ours. But a standard ultracapacitor chemistry goes from, I want to say, -40 to +60 degrees centigrade. -40 is the same in Fahrenheit and centigrade. So really, really wide temperature range. And actually during the Texas freeze, if you all remember that devastating event, the only wind turbines that were still spinning were the ones that had ultracapacitors in them. And that is because ultracapacitors go to an incredibly low temperature and they still served to power the turbine pitch control for the blade, which you need to have tuned for it to be operating. And so it is a climate resilient solution. Batteries alone won't be enough when we have cold fronts coming through as our climate continues to change and we have extreme climate events. Ultracapacitors are a climate resilient energy solution. Great question, Heather. They're all recorded. Okay. Thank you, everyone. I didn't call out your names, but these have all been wonderful questions. I'm not sure if we want to open this up for a longer form conversation. Any more questions that we have? I might be able to show you some other interesting things here.
I have a question for you,
Please.
Jose. So we need batteries. We use batteries for tons of things. And the alternative you presented sounds amazing. And I hope that it becomes cost effective for the average consumer. Don't know how long that will be, but another 2 years at least for the rollout is what you said. So I'm wondering, it sounds amazing. What are the drawbacks? You didn't talk about any of that. Are there any climate perhaps impacts that we should be aware of, or what happens to these batteries once they're done, or do they have an eternal lifespan?
Thank you for that question.
You're
That's a great, it is a really good question. The drawbacks of our technology are that we aren't eliminating batteries. We are enhancing batteries, increasing their lifespan and their functionality. And that is the impact that we hope to have, is by reducing the amount that needs to be deployed and making them last longer. The drawback is we still are using conflict mineral batteries in that process. When it comes to actually what goes into making our technology, we're still running energy analyses. Our goal actually in the biomass processing, creating the biochar, is to recapture fuel from that process using a condenser on the outlet stream to minimize the total energy input by recapturing some of that energy as fuel. And that is an open question for us, if we can make that a viable processing technique at scale. But the answer there is that this takes energy to make. It takes energy to actually turn the hemp material into a char, into a carbon powder, and then to process it into these cells. It takes some environmentally unfriendly materials in our current iterations to produce the final cell, for example, plastics on the labeling, aluminum, which is highly recyclable, but we need to ensure that we have a good take back model to be able to bring that back and separate that from our actual biomaterial. Our goal is to have a compostable cell. this is what we're working towards, and we have environmental fate testing lined up for once we finalize our chemistry. Is we will run this through environmental fate testing to determine if this ends up in the landfill, what is its effect? If this ends up back in our hands and we have industrial recycling where we can open up this cell and we can pull out the jelly roll and take the biomaterial off of that, can that biomaterial go into an industrial composter and be created again as soil and go back into the cycle itself for producing more hemp? That is the long-term vision. As an engineer and a chemist, it is a difficult thing to achieve, but that is our vision. And yeah, what I'll say is we've dedicated time, money, and effort into finding how we can maintain that vision as we develop this product. And so, yeah, there aren't any rose-colored glasses that we have on for how difficult that's going to be, but it is our goal. And I'm glad you asked that question, because that's something we really care about, is producing something that we know will have a positive lifespan, a positive total life cycle.
Will there be risks associated with like individual use? You know how they give you warnings now about don't try and break open a battery, it's very dangerous. Will you have similar cautions for these type of batteries?
Right now, our chemistry is inert. We're using a water-based electrolyte. And so, no, this would not be a dangerous cell to open. However, to move to a higher energy, a better performing product, and a wider temperature range, we'll have to explore potentially non-water based electrolytes, meaning the charge carrying part of the cell. And that would be where the danger is introduced, and potential elements that you wouldn't want exposed, just like you don't want to open up a battery into a household. Again, the goal is to remove any amount of toxicity in a product, but that is to be determined, and we have to really strike that balance of what produces a performant and cost-effective solution, but also doesn't destroy our value systems and erode what we're actually trying to achieve. This is the challenge in front of us.
Is there a price point being explored now for the average consumer to maybe prepare themselves for? Or I know you can't set it in stone, but you can get batteries today at the dollar store. You can get 4 batteries for $1.
Yeah,
Um,
yeah. I can't give a direct value on that, or rather, that is information that I have to keep confidential.
but maybe
um,
equating it with like maybe what's currently on the market, like rechargeable batteries, right?
I was about to say, yeah, um, the you wouldn't really buy this to put it into your TV clicker. You would buy this to put maybe a small mini fridge size into your garage, or maybe even a fridge size into your garage, depending on how large your house is, um, to serve as a backup system, or
Ah,
as a way to potentially carry more, if you have solar panels, to capture more solar, um, and use it for more applications. If your house is going all electric, it could be helpful for kicking on a lot of your electric systems if you're on
right.
a remote, your own grid. And that would be its application. And I'd say you can't expect anything to be too far off of a Tesla Powerwall system. So
Mm,
ballparking Tesla Powerwall, um,
right.
of course,
It's just
for
interesting.
scaled down.
Yeah, it's just interesting to try and figure out how you could possibly. I am looking for an off-grid property, and so I'm looking for alternatives, and windmills are just right out the door, and they're not recyclable, so it's not an
Yes.
energy I'm looking at. Whereas the solar panels, they're constantly evolving and they're shrinking in size, and yet they're increasing in efficiency. But will they ever be comparable in terms of the kind of system that you're talking about and the application process possibilities? So just trying to embrace what that might be in the next couple of years, and look forward to something, because I find technologies like this are not they don't reach like the broad kind of consumer right away. It's usually little niche groups who know about this. It was the same with the solar panels. It kind of rose up in little special interest pockets, and the average person doesn't realize that this well, now this technology is totally accessible and affordable. So, as time goes on and usage increases, I know prices go down, but it's just something to think about. And I'm in Canada, so I'm wondering, if that technology is going to travel north of the border.
Oh, we certainly intend for it to. And you're asking phenomenal questions and bringing up great points. Um, One on wind and its lack of recyclability and the difficulty in that. Um, Solar has its challenges too. With batteries, um, well, with our product rather, it would likely be paired with a battery system for a home. And um, in terms of timeline, in that 2024 is when we intend to do our first pilot program or secure our first pilot contract. And those can take a year to even put up, and then another year to test, and then another year for an analysis. And so, realistically, 2026 or 27 would be the earliest for any commercial product on the market for us, um, for you to purchase. And for that accessibility to the average consumer and the knowledge being distributed, this is a question that we'll be looking closely at as we move forward. But uh, you know, where we are targeting here, and it is to get to as many people as possible for off-grid living, for microgridded communities, for energy sovereignty at every level. Um, and so, yeah, I really appreciate the question.
So how will you select your beta test groups? Like, could an individual who has a space and place and land volunteer to say, "Hey, try it with me," and then, have some sort of a buyout somewhere down the line or whatever it may be. But, in terms of the beta test groups that you're talking about that will begin in a couple of years, um, like, first of all, would we check in with the university, who's your current partner, to see where it's rolling? Or as a part of this learning group, will we remain connected to a communication link where we can see how progress is moving along, and have the opportunity to get on board in some way at some point?
I love the idea of having an open line of communication, and I'll work with LaSalle on maintaining that. Our website will be the go-to place, and um, for what the archetype is of the first pilots, um, we are targeting a potential pilot at the university that we're based out of here, the University of Massachusetts at Amherst. There's a College of Engineering building going up that is intended to be a demonstration microgrid site, which would be a perfect application for us because it's right down the road from our facility, on the same campus. Another would be local utilities that are friendly to R&D for new technologies as they build out for the grid of the future. And so those are the main archetypes. Is um, they would be, you know, well-established R&D pilots within utilities that have the personnel on board to facilitate a long-term study and to give access to, standard deployments and the expertise for putting up these systems, and good, contained spaces just for this. That's the easiest streamlined path, and because they also have funding to put up these systems, because utilities are mandated and regulated to find the next technologies to allow them to answer the questions of the future grid needs. So that's the archetype, but future pilots and deployments, yeah, that's, with individuals and communities, we certainly intend to engage in that in the future. We need to be judicious at our scale with our budget and with our time. But I got to tell you, I can't wait for the day when we can start exploring a lot of pilots across all of the entire land that we're on, North America, internationally as well. All of the Americas, yes, yeah.
There are a number of questions in the chat for you as well, Jose.
Lucille, were you about to tell me the same?
Yes, I was.
All right. Will hemp make EV batteries better? From Carlos. Will hemp make EV batteries better? When deployed in an electric vehicle, such as the Lamborghini I mentioned, yes, ultracapacitors make batteries better because you use the ultracapacitor for the applications that batteries don't want to serve, which is the high power delivery, the high current draw. When you have when you step on the gas and you're accelerating, batteries don't like to output that much power. But if you can draw from the ultracapacitor bank in a baseline, and then the ultracapacitor goes up on top of that. When you want to brake really fast and dump a lot of power back into the battery, the ultracapacitor acts as a high power reservoir, capture that all very fast, and then trickle charge it into the battery. I like your dog there, if that's and that is the application of hemp. When you say, does hemp make EVs better? If you're asking applying hemp into an actual battery as opposed to an ultracapacitor, using it in the cell, people are exploring that. People are exploring hemp being put on the what's called the anode, the negative terminal, where typically it's a graphite coating to store the lithium when it's fully charged. There are groups who are exploring using hemp for that as well. It's a very, very interesting exploration. Leanne says these are all great questions. Yes, they are. Kim. So back up to existing battery banks. We have lithium ion right now. Yeah, it would basically be a hybrid system, a hybrid energy storage system in your home. It would be this from Linda. Thank you, Linda, for this. Again, the battery is the marathon runner, the ultracapacitor is a sprinter. So the ultracapacitor could be used if you're entirely off grid for starting up your heat pump system, your air conditioning. It could be used for starting up your fridge, or for when you have, it would pair with the battery to handle the high power surges. It can be used if you have a lot of fluctuation in your solar and you can't use your battery to either deliver power very fast when it fluctuates down or to absorb it too fast when it fluctuates up. The ultracapacitor will handle that. And so again, just think of them like the marathon runner and the sprinter. The ultracapacitor is a sprinter. Carlos asks, what is hemp's function in technology and why is hemp the right material choice? Hemp's function in technology, again, the sprinter. Why is it the right material choice? Because of the crystallinity of its fiber. Again, I encourage you to try and get a piece of hemp material, of hemp stalk, and see what you can do with it in your hand. It's very strong. That is the crystallinity of the fiber. It's densely packed, really tightly bonded. And Rachel asks, are you at all concerned about the amount of hemp you need to produce your products? Rachel, there are so many hemp farmers in the world and in this area, and it's growing at a significant rate. Still, yes, I do have some concern that if we truly reach scale and we're deploying and keeping up with the amount of deployments that are going onto the grid, which are massive. If anyone follows how many batteries are being deployed on the grid right now, yes, it would mean potentially millions of acres. And when it comes to regenerative agriculture, it begs a large question. What does regenerative look like? Is monoculture regenerative? We certainly don't want to see Monsanto-owned genetically engineered hemp, and to lose the matrilineal lines of the seed and seed sovereignty. There are a lot of questions when it comes to scaling, and we really rely on our partnership with true land stewards and indigenous communities to build farming cooperatives and collectives that truly maintain the sovereignty of the seed and the relationship with the plant. And we're really grateful and honored to be a part of those relationships. But that is a great question. Do we have that concern? Yes, we have that concern about producing enough hemp and how that is produced. I will say though, after attending the hemp conference, the Indigenous Hemp Conference the past 3 years, it is heartening and encouraging at how many people are doing phenomenal work in this field. And if you have a chance to go to this, I'm not sure if you did go to the conference in the past couple of years. I think this was the 5th annual. Check it out next year. It is incredible what people are doing, and it'll definitely inspire your spirit. Eliza, thank you for the question, Rachel. Eliza asks, are the sodium and zinc products you mentioned earlier batteries or ultracapacitors? What is the processing of the hemp plant to make the char? Is the entire plant used? How much hemp does it take to make a fridge-size hemp ultracapacitor? That's a great question. I haven't done that calculation yet. I have all the metrics, but I'll let you know that the process of going from hemp stalk material, which is what we use the bast fiber, and we're exploring using the hurd as well. We don't use the flower or the seeds or the roots. It's a 26% yield is what we're currently achieving. The higher the yield, the better, because it means that we get more biochar for hemp input. But that is the process. And for making the fridge from hemp, imagine the weight of a fridge and I guess divide that by 26%, and that's roughly around the amount of hemp that you need. So that's a easy, quick back of the envelope calculation. Are the sodium and zinc products you mentioned earlier batteries or ultracapacitors? Actually, both. Research groups are experimenting with zinc-based carbon ultracapacitors and batteries, and sodium is used in batteries and ultracapacitors. We actually use sodium in our ultracapacitor. That is the charge carrier in our device. It's using electrostatics as opposed to electrochemical. And so that's a difference with batteries and ultracapacitors. As in our technology, ultracapacitor stores energy in what's called an electric field versus an electrochemical reaction where we have bonding of materials. And that's why it's able to deliver power very fast, is that field can break down very quickly. So to answer your question, sodium and zinc products can be batteries and ultracapacitors and use hemp. That's a great question. Thank you, Lisa. The process for the hemp plant making it into char. It's how you make charcoal at its essence. Low oxygen environment, high heat. And then you get a char at the end of that. You powderize it, and like I mentioned, you make the slurry with a solution. Apply that onto the sheets, dry it, hot press it, slit it to size, wind it up, and put it in the can. So thank you for your questions. I would love to see, thank you, Lisa. I would love to see the portable laptop made with hemp and powered by hemp. Yes, I think we would all love to see that. Yeah, yeah. Actually, I think one of my first forays into energy storage technology was being sick of my laptop back in the day, dying so fast, and looking at ways of finding new batteries. That was one example, but I also began, I truly began this innovation because when I was young, I had some experiences of energy scarcity, of living without heat and internet, and a number of other issues in my household growing up. And that really got me asking the question of, how can I, the creator has gifted me with some talents in this life, what can I do with these to make a difference, knowing that this is a small sample of what many people live through every single day. And I found that my passion really was in engineering and in electrical systems. And so I started to ask myself, what are some of the major issues in energy accessibility, energy sovereignty, energy justice? And I found that energy storage was a key bottleneck in that. It was a key bottleneck. And so that's when I started to study the issue of energy storage, and found that batteries were made by horrible conflict minerals, and that you can make carbon-based devices to make them better, or in some ways supplant them at some level. And so that got me on studying ultracapacitors when I was in my undergraduate at the University of Massachusetts, where I studied for electrical engineering. And that was really the beginning of all of this. But yes, I would love to see a portable laptop made from hemp plastics, hemp energy systems, and yeah, what else goes into a laptop? Maybe even hemp-based conductors in there. Will there ever be a standalone opportunity with hemp because of the mining of lithium and other concerns? What is the voltage per cell? This is Linda again. Voltage per cell. What is the energy density compared to lithium? Weight per amp hour from my engineer husband. Wow, phenomenal question. I'm going to say no, I don't think anyone here is under non-disclosure, so I'm not going to answer these, but I love that these are being asked. I really appreciate this question, and if you want to know more, I would love to talk with you offline. But this gets into our highly proprietary information, and I'm not at liberty to discuss here, especially over recording. But suffice to say, they are good enough for us to secure the funding that we have and be in the space that we have to try and actually commercialize this. Thank you, Linda. Thank you, Linda. Will they ever be a standalone opportunity with hemp, as in not needing lithium? Yes, yeah. I mean, we'll still need other minerals, charge carriers. Carbon isn't a charge carrier. It's not an ion. We'll still need sodium or zinc or potassium. Highly abundant minerals would be the goal, that have a minimal footprint when it comes to mining them. So that is the goal. Are you using the boron carbide, or is that a different project? Amber White Shirt. Thank you, Amber. Some companies use silicon carbide. That might have been what you heard me say, or perhaps I misspoke earlier. But some companies create, such as Skeleton Technologies, they create carbon material for the ultracapacitor from silicon carbide. It's highly energy intensive, but it does create a very, very good material. I'm not familiar with using boron carbide in this process. And I haven't done that work. I haven't done work with silicon carbide either. Thank you for the question. All right. I think if anyone wants a sneak peek, I have some other interesting slides to share. So as some of you might gather, using the name Hempax can be difficult with some groups of people, having the name hemp in there. And so as an example, we got some questions from banks when we were trying to open up a bank account. And so we've created a investor facing and grid facing brand called Florent. Represents flow and current, is where we got the name. And this is a name and branding that's more digestible, let's say, to utilities, to potential customers, to investors. And it's just a strategic move that we decided for a certain face of the company. In investing, there's a phrase, anything that doesn't touch the flower. And so, if you will, this company is what doesn't touch the flower, because some organizations are still concerned about the use of hemp itself. And so we have our hemp processing license and have our hemp sourcing and supply chain relationships through Hempax, and then our more tech investor customer focus facing with Florent. We have a description here of how we're actually prototyping in what's called the flow cell. And then, as I mentioned, we're moving to the flow cap. This is more of the commercial product. This coin cell is a standard watch battery. It's what you have all seen, I'm sure, at some point in your lives. And it is a standard academic and industry standard form factor that allows us to have rapid prototyping and try out new chemistries without getting the whole manufacturing line up and running and doing a large run and creating a lot of material. We can use a small amount of material, save a lot of cost and time by producing in the coin cell or architecture, what we call the flow cell. And this is a view of our intended product line. And so, as I mentioned before, these flow caps are the building blocks of what would be the flow mod. So 36 flow caps go into a flow mod. And then 6 of these flow mods go into a flow rack. This is that refrigerator sized rack. And up to 25 of those go into a shipping container. And this is the prospective timeline for the prototypes. Oh, here, this is a good slide too. This shows all of the applications on the grid. Apologies if this is a bit semantic or jargony here, but there are different levels of the grid. There's transmission and distribution, there's end users, there's generation. And so ultracapacitors have a application in what are called grid services at many levels of the grid. They offer what's called virtual inertia and frequency response. So we know that our grid is at 60 hertz, right? And sometimes when you bring on new generators and when you have diverse loads, you can have a frequency that sways and shifts from 60 hertz. And you need to deliver power very fast or take power away very fast to maintain an even waveform. Ultracapacitors are really great at doing this service. There's peak shaving, as I mentioned before, when you have peaks in demand and supply. There's power quality and voltage support. So when you have dips in your lights at home, if anyone's ever seen that, when you have, you know, a small dip or a little brownout, ultracapacitors will eliminate that, that voltage drop. Black start is when an entire grid goes out and you need a lot of power to start everything back up. That was part of the problem with the Texas freeze, is when some of the grids went out, they didn't have the capacity to start everything up, even if they had the capacity to keep it running. There's always a lot more power needed to black start. Backup power and buffering for residential, commercial, industrial buildings, buffering for fast charging and the e-buses, like I mentioned, for microgrids. And I had mentioned also the turbine pitch control for wind and ramp management for solar and wind. So that means that when you have really fast fluctuations in renewable energy output, you need to be able to absorb or make up for that fluctuation in the grid to keep it stable. And our devices do that very, very well. Any questions on this story of grid applications or anything else so far? Well, I think that's the extent of the slides I have to share.
This was very inspiring. Thank you so much, Jose.
Yeah, really, really happy to have to been here and to get all of this engagement. I really appreciate all the questions, and I hope you all walk away with something a bit more than what you walked in with.
Yes, thank you so much. We really appreciate you spending the evening with us and teaching us about HempAx and all the amazing work you do. And keep up the great work, and congratulations. And we look forward to seeing what happens in the future also. So thank
Really
y'all so
appreciate
much.
that.
Absolutely.
Thank you. And yeah, please be in contact if anyone has any follow-up questions. Always happy to chat.
Where's your partner? Where's my buddy?
Oh, yeah, it's good to see you.
Nice to see you.
We met at the Hemp conference.
Yeah.
He's in New York right now, but I'll be seeing him in Denver next
All
week.
right. Yeah. Tell him I said hello.
I will. Great to see you. Well, thank you, everyone.
Yep.
I'm going to sign off now.
Thank you. Thank you so much, Jose. Appreciate it. Have a good evening.
Bye-bye.
Well, everybody, that is week 8, y'all. I mean, gee, you know, this has been so amazing. There's some people who, you know, you could just really see the inspiration, like, especially when he expressed very